Hey everybody, this is Larry. This is the last day of January 2021. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Next permutation. Yeah. Yeah, so everyone I hope y'all have a great January. It was, hopefully it's the beginning of the year. It's still tricky, but, it gets better. Fight on as much as you can and take care of yourself. It's a long journey packed for a long trip. Okay, so today's problem is next permutation. Implement next permutation. Okay, so this is actually this is way annoying. Only because because this is like a textbook algorithm, right? And I don't really have a great way of describing it or explaining it. And to be honest, there was like a lot of videos on this exact problem, either inside Leetcode and outside Leetcode. But what I'm gonna focus on is not really the explanation, because I feel like I said, like it's just not very how do you say this? Like it's just very standard, right? There are a couple of ways to visualize it, and if I were to get this on an interview, that's what I'm going to try to build those visualizations for you so that it helps. But I think honestly, like it's something that like you do it a few times and you kind of get used to it. And I'm going to try to play around with different ideas to kind of let you, the constant extra memory is also kind of annoying, but like I'm going to try to explain kind of my intuition, because like I said, like it is a textbook solution, and in theory, in that sense, like it's a very known answer, but it's also like a memorization thing, because if you don't then like it's just hard, right? And I think the other thing that I just noticed is that the digits are not unique, so that makes it a little bit trickier, but it's still like the same idea. The idea, and for these kind of problems, and maybe not this particular problem, but these kind of problems, I would play around with, and usually, to be frank, I do it on paper, but obviously I don't have an easy way to do it on paper, so I'm just going to do it. But the idea is that, okay, I would go over some like small cases, go on to, and just kind of see if I could find any pattern, and yeah, right. So like that's one trick that I might use. This has no dupes, but so like a dupe would be something like that. So yeah, so there's kind of a couple of things like this where I just kind of see if I can figure out the pattern, right? And by pattern, I probably also mean invariant in this case, because you're trying to maintain an invariant in this problem where, and I don't even know how to quite describe it, because to be honest, this is like just such a, it almost feels like trivia, right? Where like, hey, do you remember this thing? And if the answer is no, then at least for me, because I just feel like, another way to do it, at least help you to get, like, it may not be the optimal answer, but to even just get you one answer, even though it's not quote unquote good enough, and this is like a well-known enough problem that it is literally on Wikipedia, right? Like, so it's not even, so I'm not trying to be, like, not trying to be that lazy per se, but it is literally on Wikipedia, so like it's like, well, I don't know that I can, on the spot do better than Wikipedia. But another way that I would maybe visualize it on a contest, on a contest as well, but also on like on an interview, and this is not going to be constant time, is that, okay, so this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, right? And the way that I label these are kind of obvious, and this is 0, 1, 2, say. I mean, the labeling is not that hard, it's not tricky, but the thing that I want to think about is that, okay, so in this case, to get the next permutation, I can just figure how to convert this number into this number, and then add 1, and then convert it back, and then do it again if you want to, and then keep on going, right? And that is also another way you can do it, so that if you're more familiar with that, and And I think also that it is more generic. Like if it's not, in this case, next permutation is, like I said, a textbook problem. But if you're given like some sort of rules and you want to add one, that's basically how I would do it, is that I would maybe convert this back and forth and then kind of get the pattern that way. And because you can usually do this transformation in linear time, and then the D transformation, or the back transformation also in linear time, like that should be fast enough. Of course, you're not going to be able to do that in place, so that's going to be O of n space as well. But that's just an idea that you can do to play with, right? Yeah. So it kind of I mean, I think the thing is that I can explain to you the invariant, and I'm trying to think about it, but it's just like it doesn't really help you solve the problem, right? Because for me, the key part of why I do these videos is that I don't want to just explain the solution. Explaining the solution is fine, and it's good for a lot of things, but it's also like, well, can I explain to you the solution in a way that you can do it again next time, or do a similar problem but not the same problem using the techniques, right? And in this one is way trivia-y, so that's why I try to talk about like this technique where, you know, you can maybe use that elsewhere. And, you know, for invariants, and I am kind of talking a lot for this particular video, but yeah, in this invariant, it is just, for this problem, the invariant is just trying to find the first place in which, how do I say this? Try to find the first place in which the number is next to, or the last number is bigger than, or the previous number, like going from the right to left, the previous number is bigger than the number before that. And, you know, that, and then for that number, you swap. That's kind of the idea. And that's the part, as I was saying, is that it's kind of hard to figure out why that is true from the scratch, and I don't even have a good visualization about it, to be honest. You could play around with permutation groups and stuff like that and kind of get that idea, but to be honest, I don't know how to explain it in a good way. So I do urge that if you do want to understand it, you know, maybe there's a better video. And I'm not like, I don't set up my videos to be the only one place you should go. You should definitely, I think for every problem there are multiple visualizations, and sometimes I'm good at giving you multiple visualizations, and hopefully, you know, one of them will stick. But in this case, I just feel like it's so trivial-y that, you know, if you could find a better video, let me know, or post in the link below, and then we'll kind of work together, and maybe I can learn how to teach it next time as well. But it's like I said, it's kind of tricky to do these one-off-y things. So maybe I just need to learn a little bit better how to teach this as well. But yeah, once you find that, yeah, and once you kind of swap, you know, these adjacent, you know, the first kind of thing that's in order, once you swap that, you want to reverse the rest of the array, because then now everything after that number, we want it to be sorted, kind of. And what I mean by that is, okay, looking at 2, 2, 1, so then now we put a 2, but then we want to make sure that the rest is in ascending order. And why is that? Well, the simple thing is that you can look at it as incrementing a digit or something like that. So once you increment a digit, all the digits previous to that are zeros. And in this case, in permutations, the bases are not static. I think that's the only kind of, that's one way to think about it, but it's not the only way to think about it, of course. It's just like some sort of not factorial base, but like Waring base that you can calculate by factorial. Okay, so I'm going to start kind of coding and kind of muck around with it a little bit. I might even not get this correctly because it's just been so long, right? Or like, it's just like I said, it's trivia. I probably even have a video on this already, to be honest, now that I think about it, but we'll see how I explained it last time. I don't really remember it. So okay, so now we start with yeah, the last two characters, and then, you know, what, yeah, I mean, it's a numbers, right? Is it no, the other way, as we said. Okay, so this is the last character. No, this is the last character, and this is the second to last character. So if yeah, if there's any inversion, then we keep on going, right? We want to go to find the first place in which that the numbers are kind of next to each other. So yeah, for example, again, if we have like, I'm just trying to give an example. I'm not only giving an example, but I'm just trying to think about it in my head. So here, and maybe this is a little bit awkward for me to see. So let's go the other way. Because this is the second to last character and this is the last item. So if this is bigger than that, then we keep going. Like for example, if it's 7654, this is bigger than that, we keep going, and then okay, we find the 3 7, right? Then now what, right? We move the 7 to the 3, and then here we basically want to sort the rest, except that we know, well, we want to sort the rest, but we also know that because of this property, we know that it is incrementing. It is increasing from the back, so then we just reverse it. So we go to 4 5 6, and then next we do again. So then 6 5, and then next we do 5 6 is good. Is increasing 6 4 6. So convert it to that, and then next loop again, right? So that's kind of the idea that we're gonna go through. Yeah, and also if index is -1, we have to reverse it, and that's just. This part is a little bit silly and not in usual next permutation. Usually you return none or something, I don't know. But basically it's just because if it's not possible, you give it to the beginning, which if it's not possible, that means it's the last possible thing. So you want to just reverse it. And then now we do it again. Let's use index minus. Yeah, so what do we want to do? Yeah, right. So we swap these two. Why do I? Index 2 is equal to index. We'll make sure which one. So okay. So first we start here, then we here, then here. So this is 2. So this would be the 2, and so x plus 1 is this is the 7. So we do want to swap. I think. And then now we want to reverse it from, which one is index 2 again? Index 2 is this one. So we want to swap the one after that. So index 2 plus 1. Yeah, index 2 plus 1. Oops. But we want to, can I reverse this in a easy way? I don't know. I think the way that I remember last time I did it was something like this, and then I just kind of do while left is less than equal to right, or I guess strictly because if they equal then they're already the thing. Then we just swap left and right, and then left increment 1, right 1. And I think this is it. Maybe I might have an off by 1 somewhere, so let's kind of give it a go. I think that was one of them. Let's try another one. Just random numbers. Let's see. Let me look at the constraint where I do it. 100. Okay, that's fine. Looks okay. Let me give it a submit just because I'm a little bit lazy and I don't care that I get a wrong answer. But oh no, huh? Did I misunderstood some part of this? Okay. Did I swap the wrong numbers? Okay, so 1 3, we definitely want the 2 to go to the 1. Oh, maybe I just kind of spread up a little bit too much, because basically what I was is that, okay, so for example in here, if we want to swap the 7 and the 2, is that right? What am I doing? Okay, let me look at that case again. I'm just being a little bit wacky. Okay, 1 3 2. We want the answer to be 2 1 3. That's obvious. But what I did instead was that I swapped a 3 and a 1 for some reason. What I want is actually swap the next number, which is the smallest number, which is the last number, right? So okay, so how do I do this? I So basically, I want the next number that's okay. So basically, after I, as I say, increment, let's have something like this, and this is perfectly whatever. Yeah, why isn't this just always the last one? Because if I have to swap these two, well, wait, let me go back again. 1, 3, 2, right? Yeah. So I think I just take the last one. Why did I? Well, what is the easy way to do this? So the easy way to program this is well, is there another way? Or like I'm trying to think about the wrong cases. Like okay, let's say I have 8. Man, I don't remember this. Yeah, okay, let's just try it this way. Then what is the next number? The next number is actually not 2, right? Even though 2 is at the end, the next number is actually 4, because basically what we want is kind of quote unquote increment the 3 and not really a swap. So I think I got something confused along the way, which is fine because it was silly. So yeah, so now we want to increment this, and then well, we move the 4 here, and then we move the 3 here, and then oops. Sorry. I guess another way to think about it is that because we can't move the 2, because if we move the 2 here, then it doesn't make sense. So we want to get the next number that's bigger than the 3, or equal. No, we need the next number that's bigger than the 3, because if it's the same, then it would not do the same. So okay, so then we could just swap, and then also reverse the rest. Okay, so that's basically what we will do. So let's do that. Like I said, I have to go through more cases. I think I just, yeah, I didn't go through enough cases because I had too many numbers, so I got a little bit confused. But okay, so instead of index is this, we start from the end maybe, and then while index 2 is greater than or equal to index, and num sub index is greater than or equal to num sub index 2, we decrement. Hopefully that's right. Is that enough? Nope, still wrong answer. Oh yeah, now the left is not the index. Now left is we have to go back to the original index. Yeah, I erased it, but okay. Okay, so that looks mostly good. Let's give it some. Oh, let's actually. Oh, we deleted it, but okay, fine. Let's do 1, 3, 8, 7, 6, 5, 4, 3, 2, 1, maybe. And in theory, it should have a 1, 4 prefix. Yep. And then the rest is sorted. Okay, so I'm more confident. Let's give it a submit. Okay. I mean, like I said, I don't really like this problem. It's just too textbooky, and I apparently forgot the trivia that I kind of rambled on about. And the invariant isn't even that, like either you know it, or I don't know how you could like derive it from scratch that easily, to be honest, if you didn't already know it. I think if you have to talk about invariant, it's just that I think the easiest way is thinking about a variable base, a factorial base. I don't remember the actual mathematical term, but if you think about it as a number and you kind of convert it, I think that's the way that I think about it. But it's a little bit or a lot messy, to be honest. But you can probably prove from that principle, and that's the way that I would think about it, and that's the most consistent way to kind of do it. But yeah. So what is the complexity? Well, in terms of space, we modify everything in place, so it's going to be constant extra space, which, I use a couple of variables here. And in terms of complexity, well, you have this while loop that could be O of n, and this could be O of n, and this could be O of n. So it's going to be O of n altogether. Yeah, that's all I have for this farm. Like I said, I'm not really a big fan, and let me know what what other videos that you watch that are better than this, because I'm support to that. But yeah, let me know what you think. Everyone do have, I hope you had a good January. Mine's been a little bit rough. Life is fragile, I hope you treasure it. I know that, I, there are a lot of reasons to do, interviews, whether it is, to get better job opportunity for money and all that stuff. But at the end of the day, it's the people that counts. It's the people that matters. It's the people around you that should give you meaning. And I hope that you take it to heart. I made that mistakes before when I was younger, and it's probably one of those things that everyone has to make some mistakes around. But still could talk about it. But in either case, treasure your health as well. Your health is the only wealth that matters. Maybe. And yeah, and lastly, to a good mental health. February is next. I'm gonna do it. And it's a short month, so it's the easiest month, right? To do all 28 days. I will see you later. Bye bye.